This is from the AMC 8 exam from 2004, and this is problem 25. In case you're not familiar, the AMC 8 is a math competition for middle school students. With that out of the way, let's get right into the problem. It says the following. Two 4x4 squares intersect at right angles, bisecting their intersecting sides as shown. The circle's diameter is the segment between the 2 points of intersection. What is the area of the shaded region created by removing the circle from the squares? And we're given this strange looking shape here. Now, just like in the geometry SAT problem that I covered the other day, we can tackle this problem by just breaking this down into steps and hopefully breaking down the shaded region into shapes that we know how to find the areas of. So if you look closely, what we have is this shape here, which consists of two squares bisecting each other, okay? And then we have this circle that's in the middle of the two squares. So if we can start by finding the area of this shape here, then if we can find the area of this circle that's been cut out from these two squares, and we subtract these two areas, then we'll have the area of shaded region, which means that we're going to have three steps here. Step one would be to find the area of the bisecting squares. Step two is going to be to find the area of the circle cut out of the middle. And then step three is going to be subtract the areas found in steps 1 and 2. All right, now we have a framework for tackling this problem, so we can just get started with each step. Our first step is going to be to find the area of the bisecting squares. I just drew this shape ahead of time just to make things easier for the sake of the video. But essentially what we have here is two squares that are overlapping. I want you to pay close attention to this section here where the two squares overlap. If we add the areas of these two squares together, the two big squares, then this portion here is going to be included up twice. So what we need to do is find the areas of these two big squares here. And then once we find the area of these two big squares, we just have to subtract from that the area of this small square. That means we're going to start by finding the area of the two big squares. Now these are two 4x4 squares. So these squares have a side length of 4, which means that the area of one of the squares is going to be, and I'm using SQ here, which represents square, 16. Area is going to be 16 because this is the same as 4. I'll just write this out for clarity. That means that the area of two of the squares is 32. I'll say 2 times the area of the square is 32, because 16 times 2 is 32. Now we just need to find the area of this small square here that's in the middle. And in order to do this, we're going to use the fact that we have bisecting sides here. Since the sides are bisecting, we know the length from here to here is 2. Bisecting means split in half. Since the side length of the square is 4, that means that half the side length, which is what we want, is 2. And then same for this side here. And that tells us that the area of the small square, I'm going to say area of square, I'm going to use S to represent small square, is equal to 2 times 2, or 2 squared, which is 4. So the area of the bisecting squares is going to be the area of the two squares minus the area of this small square in the middle, which is 32 minus 4, which is 28. And I will write this in green. This is the answer for step 1. Okay, now the second step is going to be to find the area of the circle cut out of the middle. Now I copied this shape from step 1 because this is going to be important for the second step. I would say to pay close attention here because this step is a little bit trickier than the previous one. Now what we have here is a circle which has a diameter that consists of the 2 points of intersection. Now I did still include the side lengths of this small square inside here because that's going to be important. Now since the diameter of the circle consists of these 2 points of intersection, I'm going to draw a line here connecting the two. And if you notice, we have a right triangle. All we have to do at this point is find the hypotenuse. You might be thinking, how is that useful? Well, if we think about the formula for the area of a circle, once we find the radius, then we'll be able to find the area. And we also know that the diameter of a circle is twice the radius. I'm going to say D is equal to 2r, where D is the diameter and r is the radius. So once we find a diameter, then finding the area of the circle will be pretty straightforward. Now going back to our sketch here, since we have this right triangle that's formed, all we need to do is use the Pythagorean theorem in order to find the length of the hypotenuse. Okay, I'm going to say, let's say this is D. Pythagorean theorem is a squared plus b squared is equal to c squared. So in our case, a and b are both 2. I'm going to write 2 squared plus 2 squared is equal to d squared. 2 squared is 4. 4 plus 4 is 8. Now we have 8 is equal to d squared. And we can take the square root of both sides to get that square root of 8 is equal to d. And this is 2 square roots of 2. I just simplified this radical quickly. You can also recognize that we have a special triangle here, a 45, 45, 90 triangle. Since the length of the side here is 2, we can just take this length, multiply by the square root of 2, and also get the same answer for D. 2 ways to do this same step, but both ways get you the same answer. It doesn't matter which way you do it. All right, now that we have D, we can find R. And if we go back up here, we know that D is equal to 2R. So we know that 2 square roots of 2 is equal to 2R, which means that R is equal to the square root of 2. And now that we have R, we can find the area of the circle. The area of the circle is going to be pi times square root of 2 squared, which is the same as 2 pi. This is the area of the circle, 2 pi. I'll also write this in green. Okay, so the area of the circle is 2 pi. Put this in a little green square. And same thing with this answer. All right, now that we found the area of the bisecting squares and the area of the circle cut out of the middle, our third step here, the easiest step, is just going to be subtracting the areas found in steps 1 and 2. And that's just going to be 28 minus 2 pi. which means that our answer here is D. Okay. I know this problem had a lot of steps, guys, but the way we approached this problem was similar to how we approached that SAT geometry problem we were working on a while ago. We just break the problem down into smaller steps, and for these geometry problems that involve strange, weird, and unfamiliar looking shapes, we try to break those shapes up into shapes that look more familiar to us, shapes that we know how to work with. We also had to know just a little bit of triangle geometry. That's always important. If you have any comments, feedback, or suggestions, or any questions, please let me know in the comment section. Otherwise, I will see you in the next video. Have a great day, and I'll talk to you all later. Bye now.